Okay, in this lecture, I'm going to talk about distractions in Houdini, and this is the scene we're going to try to build today. This is a ball which will distract this column, and here is the animation. So as you can see, the column is just breaking apart and falling on the ground, and Houdini has a really strong physical engine, so the simulations can be really natural. And okay, this one should be pretty simple. Okay, to start, we need to create a new file, absolutely new one, and let's create a geometry because we need to import our column first, and let's call it column like this, and here is the file. Okay, now it shows the previous part of the column when I was preparing. Okay, and now we need to import our file. So we create a file node, and then in geometry file, I need to type $hip / column obj. This is my column, and it stands in the folder here, column distractions heap. So you need to save your file first. So this folder become a heap folder like Houdini project. Okay. So this is solid object, no shattering, no cracks. Okay, and to move forward, we need to create points because shattering in Houdini works with points, and we need to feed these points into Voronoi fracture node. Okay, first we need to create a points cloud, and to do this, I need to create scatter sub. So I hit tab, typing scatter. It creates a scatter. Here you can see number of points. So this is basically number of points we'll get after we connect input. 5,000 is quite a lot. We definitely don't need so much because it will bring us into situation where we have too much pieces. Okay, so I set it to 200. All right, and now I need to create a Voronoi fracture. Let's start from this. The Voronoi fracture has 3 inputs. First one is geometry, second points, and third one SDF, which is volume, and this is a bit advanced, so we're not going to touch this. So first, let's connect our geometry, the column, into first input, and then scatter into second one, like this. Okay, and it generates the pieces for me. Yeah, this is quite a lot of pieces. Okay, in Voronoi fracture, there is checkbox visualize pieces. So if I hit it, I got a unique color per piece. Okay. If I move back to scatter, so just select scatter node and change number of points to, let's say, 50, you can see that it changed amount of pieces. Right, and here is a random seed, so you can change it as you wish. Okay. In Voronoi fracture, no, there is few tabs, which is cut. this, if you change it, it will make pieces a bit smaller, so, and give you a little gap between pieces, like this. There is a cluster which will combine pieces together inside of node. Interior, which is really interesting. And to see how it works, I need to create explode view. Explode view, connect it. And here you can see that all my pieces is moved away, moved apart. And all of them are black, which is not correct because it's because of normals. So I put facet node after Voronoi fracture and hit pre-compute normals. Okay, now it's fine. All right, so interior detail. Okay, let's activate this checkbox, and it gives us more geometry, more details on inside inside of each piece. Because if I deactivate explode view, you can see that column is like it was before, but inside it has details. All right, so here we have detail size, and if I increase it, the details will be smaller. If I decrease it, I will get more information, more distortion. But be careful because too small values can force you to wait too long. Depends on your machine. So 0.05 gives me this, and I can try to go lower, and it takes a bit to calculate. Here you can see the line which tells you what's going on here. So if you see this, just wait a bit because Houdini calculates something important for you. And okay, great. Now I have a lot of information. It looks really awesome. And if I turn this off, the wireframe, you can see that I have, it looks like real rocks. Okay. Noise amplitude, which it will give more, like amplitude of noise applied will be bigger. Probably I need to increase detail size because it takes a bit to calculate. Okay, and amplitude is too big, so I get ugly pieces, but that's how it works. Let's do something like this. Okay, now it looks better, especially from distance. Okay, noise type. This is fair for any noise in Houdini because it uses the same algorithms. So Perlin noise. Oh, okay, hit escape to increase the detail. Let's say 5. Okay, recalculate Perlin noise. Original. Well, it's a bit hard to see the difference now because the resolution is small, is low, and you will see more details once you have a higher resolution. Okay, frequency, you can increase this, so it will give more bumps. Okay, offset is just basically offsetting the noise. Turbulence, it's affecting the strength of noise. Volume resolution, it's for volumes, which is not connected. No. And here we have ramp, noise ramp, which can control our noise really precisely. So you see I can do this, and basically when it's in the bottom it says that there is no noise. Well, at least it should be like this. Yep. So you see now I have perfect flat geometry, but if I do like this and add more points, I got uh, more distortion. So you have a lot of control about what's going on. Okay, and to make calculation faster, I would recommend not to activate this checkbox until you're happy with your simulation. So just be done with simulation and then activate it and tune it up, because otherwise it will take forever to you to get a nice result. Okay, groups. It creates here. It creates a groups interior, which is I can show. If I create delete node, I can delete specific groups. So let's attach it here. Okay. So if I delete inside, only outside will stay. So inside group contains the polygon which is inside, and outside obviously contains opposite. All right. But also you can delete a specific piece. If you click on this triangle, you can see the at piece number. This is not group. This is attribute. So it's a way to assign get access to the attribute in Houdini through at symbol. So let's say I want to delete the piece number 16, and it disappears. So you see, no piece 16. And then let's say I want to delete piece 18. Okay, piece 18 is here. So they are not sorted or something. It's just random numbers. All right. So let's leave it like this. Okay. Now we have all the pieces, but if I play animation, nothing happens. Right? This is because we just shattered geometry, but there is no simulation. To make it dynamic, we need to do a few things. First, let's go make sure that you're in the end of flow here. It can be any node you have, but just make sure that you're in the end. Okay, now go up one level and switch to rigid bodies tab. Here you have ground plane, which is basically infinite ground, and we have to have it to make our geometry collide with ground. So I create this. Oh, and to create it, you need to create it in the center of the world. You can hold Control and click. Okay. So we have ground, and Houdini creates AutoDop network and ground object for us. Ground object is basically predefined thing, so nothing to do here. But AutoDop is dynamic simulation network. So here we have ground plane. I'll talk about it a bit later more. So now let's go back. And to make this dynamic, I need to select the column and hit on RBD fracture object. Okay, and it asks me about what type of fracture object I want to create. Well, in our case, we need to create fracture object, not the packed, not. So I hit on fracture object. So now each my piece become active object. So if I start animation, it will fall down like so. Okay, and you can see that playback speed is a bit weird. This is not natural. It was slow in the beginning when it's caching, like here. But after caching is done, it starts to blink really, really fast, which is not real time. To fix this problem, you need to click on this button, which is real time toggle. And in Houdini, this button doesn't affect the particles or other simulation like in Maya. So you can safely click on this and it will play in real time. Okay, so let's clean reset simulation on Autodop and play again. Okay, it's slow now because it's caching, and when it's done, it should play at real time. Okay, this is real time. So you see, it's if I turn this off, everything becomes really fast. Okay. Now, what if we want to? Okay, let's talk about optimization first. Let's say we don't want to crash the whole column. Let's say I want to crash just this part, the upper one. To do this, let's delete our Autodop just to avoid any issues and the ground. Okay, and let's delete everything here. So just a column. The goal now is to simulate to crack only this part, for example, the upper one. To achieve this, there is a few ways. I will show just first one, the simplest, and maybe more. Yeah, okay, I'll see. Okay, let's create a scatter node like this, and you see that there is a lot of points, 5,000. Now we need just two points. Okay, and 1, 2. Let's create a Voronoi fracture. All right, and here I have piece number 1, piece number 2. I will turn on visualize pieces, so now we can see. And in scatter, there is a random seed, so I will move it until I'm happy about how it looks. Something like that. All right, now I have two pieces, and we need to work only with this one. Okay, and there is an easy way to to split them up. Let's create delete node, and actually we need to. Let's name this branch bottom. So here we have just bottom part, and like this. And let's copy name, copy parameter, paste relative reference, and delete non-selected. So on this node, we'll always have opposite part, opposite piece. Okay, so the workflow now is pretty the same. Create scatter node, points, say 50, Voronoi fracture, and connecting first input to geometry into first, points into second. Okay. There is one node which add a bit more control, and this called, let's delete Voronoi fracture, and this called Voronoi fracture points. Okay, it also has three inputs. First one, geometry, second one, points. And now you can see there's envelope geometry, which basically tells where the point cloud generated. And if I switch into here, you can see there's impact radius. And if I change it, the envelope will change. Points per area. This is how many points there will be. Volume resolution. It's more for SDF here, which we don't have SDF. And random seed. Okay, point density, you can adjust this. Let's go back to default. Okay, interior and exterior. It basically defines how many points should be on top of surface, inside, and so like this. Right. And now we have geometry, scatter, Voronoi fracture points, and now we need to create a Voronoi fracture by itself. First, geometry. Second input is going from Voronoi fracture points. It calculates a bit, and here is my point. All right, and this is envelope. If I change the impact points per area first, it will give me less pieces. All right. And if I change impact radius, it also affecting the number of points. After some value, it's stopping to affecting the geometry. Okay, let's bring it to default. Okay, this is the one way to work with piece of geometry, but again, it creates it's shattering the whole piece. What if I want to define some specific point of impact? Well, to do this, I will delete this node. So I have the solid geometry here. To create some specific point, there's a few ways. The first one is use actual geometry. I like this way. I like this method more because it's more flexible. So I create a sphere. Come on, sphere. Sphere. Or any geometry. It can be a cube or something else. Okay, the sphere. And I need to create a scatter node. So it basically create point clouds on our sphere, and let's say 50. So this is our points, this is our geometry. Now we need to create a Voronoi fracture, like this. I connect geometry, I connect points. Well, it's scattered, but the thing is that sphere by itself is under geometry, so it's not really affecting this. To get more control, I will create the transform node like this. So now I can control my sphere. You see. And let's make it smaller, like this. So now I can precisely define where is my impact. So pieces here are bigger, there are smaller, and if I increase number of points, I will get smaller. Okay, and if I turn on cluster, it looks like this. Okay, let's bring scatter number of points back to 50. Maybe deform a bit the geometry, like this, for example. I don't know, it's not really important now, just for fun. Okay, so now I have pieces here now, and here I have solid geometry. Cool. To make it dynamic, I need to merge it and apply RBD fracture. But I want to show one thing. Oh, first, okay, I will make a tip. Okay, this is tip for myself. Really useful feature in Houdini. So you create on this one, and it creates a sticky note for you. Like, let's bring it down here. All right. This was a first way to create a specific impact point. Another way to do this is to use a color as an attribute. All right, so another way to get a specific impact point is to paint it. So to do this, let's we need to take a geometry. So let's start from our file and move this on side. I need to create a point sub, and add some color information to our geometry. So I select point sub, keep color, changing to add color, and delete the channel. Okay, so the column turns into black. And now I need to create a paint sub. Paint. And let's set our color to red. And here on the left side, you need to activate this icon to make it possible to paint over. Because if you have this, you will you can't draw. Okay, so you shift to this one, and your mouse changing the cursor, and now you can paint over with red color. It basically defines where impact points. Okay, let's say this. Right, and now I need to create a scatter sub again. And in scatter sub there is alternate attribute field, and you need to create you need to select a color. Okay, immediately you can see that on places where I draw the red color, there is more points. Well, at least it looks like this, but basically now it's 50-50. So, and there is attribute bias, and if I change it, you see that if I set it to 0, my attribute has no effect over spreading of points. And if I set it to 1, I will have points only where I draw something. Okay, I will leave it at 1, and now I can create the Voronoi fracture, connect it. Okay, it calculates a bit because there is 5,000 points, which is a lot. Okay, and visualize, and you can see that I have really small pieces on place of impact. I'll set number of points to 50. Well, in this case, it's hard to see. 500. Yeah, great. So now you see that it's really affecting the geometry. Okay, but this was with whole geometry. What if I want to have this with my half? For example, with this piece. Well, it's a bit different because if I connect it now, this won't work. Just to prove this. Okay, and my attribute doesn't work. It's like it's changing, but it's not affecting the geometry, the impact point places. Okay, to fix this, I need to cache my geometry. And caching is also helpful when you do simulation because it really helps you to save time on loading, changing objects. So okay, let's create. Oh, let's rename this. This is upper part. Upper. I'll put it here. Deactivate. Or okay, I'll delete it. So I have this part, and I have this part. Cool. Let's cache now. I create a file node here, and I actually need 2 of them for each branch. And I connect it. All right. And in file node, I need to switch file mode from read files to write files. Okay, and here I need to set name $heap for Houdini file project folder, and let's call it bottom geo. And the extension of the files is bgeo. It can be just obj, but bgeo is a native Houdini format, so it's always better to have something in native, and you always can change it. So okay, bgeo. All right, and let's call it cache bottom out, and let's copy name cache upper out. Okay, because here I'm writing down the upper part. Write file $heap slash upper geo bgeo. Cool. So now I have 2 files. You can see that it's upper geo, and it opens a gplay, which is this is a tool which can play all the simulations, cached simulations and stuff. So this is upper part, and this is bottom one. So okay, so let's go back to Houdini. So now I have 2 cached files, and I can take my piece of network and connect it to file from folder. To do this, I need to read this file. So I create a file node again, And let's copy file name, copy parameter, paste relative reference. All right, and I need to change file mode from, well, it stands read, so fine, but it's locked. This one is locked. If you meet this problem again at some point, just know that you need to connect something to file node, and then you can change it. So, but now I don't need this, so I break it. Okay, and let's connect. Let's name it cache upper in, because we bring in our cache geometry. Okay, and now I connected this into my piece of network. It calculates and nothing happens. The reason is that when I was caching the geometry, it has all the attributes from here, from previous. And therefore it's not working really well, because I need to clean up my geometry before I import or export it. Sometimes you want to keep it. For example, if you cache the simulation, or which will be uh, brought to somewhere else, and you need all these attributes, but now I don't need this, so I want to clean this up. To do this, I need to create an attribute sub attribute. I need 2 of them. Okay, and I need to put them between before file sub, like this. Oh, and also no, it's fine. Okay, never mind. Okay, in attribute sub, I need to switch to primitive tab, since we're gonna work with primitive. And in delete attributes, I need to type asterisk, because I want to delete all the attributes. And in keep attributes, I need to delete this. So basically reverse. Do the same on here. Don't forget to switch to primitive, like this. And after you did this, you need to go through the flow and just to make recalculations, and you need to write your file down again. So let's see if it's will be visible on here. So now my upper geo is 60 kilobytes. I reload it, and well, it's again 60, but yeah, it just changed, believe me. Okay, and do the same here. So now my geometry cached and it's clean. So when I import it back, you see it's even changed the color. When I import it back and activate my network, it works. Okay, cool. Now I need to import my bottom part back. To do this, I create a file node. It stands, and okay, I copy file name, paste relative reference, like this. It stands in read mode, so I always will read it, like so. And now I can merge them together. Okay, looks pretty nice. All right, so I will create a null sub just for myself, and let's call it out sim. So it basically tells me that from this point, everything will be sent to everything that before this point will be sent to simulation. So I switch flow to here, to last node, go one level up, and here I create my ground. Right, I'm playing and nothing happens. Well, sure, because I not activate the column by itself. So I select column node and clicking on RBD fracture object. RBD fracture, and now let's play. Okay, and you see that it's really slow. But it looks nice. Okay, so this is what we have. And it calculates kind of slow because there is a lot of pieces. So I will go back and change amount of points in scatter sub to 100. So calculations will be faster like this. Okay. Now it's crashing. The bottom part is standing still, and only the upper one is affected. But what if we want to have our column static until something is hit? So to do this, you need to go one level up to the object level, and you need to select nothing. Then on rigid bodies tab, there is an icon with a glue box, a glue tube, and it's called glue adjacent. So let's click on this, and the blue line under here tells select RBD object to glue together, and press enter to complete. Important thing here that after you select the RBD object, and it selects here, your mouse, your cursor must be over on top of your viewport, not here or here. Because if it's placed somewhere here, the enter command will be not taken by glue node. So put your mouse on top of here, of viewport, and hit enter. And after a few seconds of calculation, it creates a few nodes inside of Autodub. But first, let's see more about Autodub. So this is Autodub network, automatic dynamic. I hit L to sort everything to layout. Ground plane, here is nothing interesting. This is just static object, the ground, static solver. Column, this is a dynamic object, so the icon tell us about this. And in column, we have initial state, which is basically tells initial parameters to the simulation. So rotation defines rotation of the whole object. Okay. Velocity is defining the initial force. So if I set it to 5 here and we'll start the animation, you see that in the beginning there is like a little impulse. If I set it more, like 50, like it's too strong. Okay, too strong. But looks really nice. So now it feels like something is hitting the column really hard. If I set this velocity to 5 here, on y-axis it just goes up and cracks. Okay, it's not cracks because we have a glue node. Okay, but if I set to 15, it will give more force into impact, and the column will crash. Alright, and angular velocity. This is basically velocity which applied to the angle. So the object will basically spin around the axis. Okay, to make it visible, I need to do this. So the column will go up and then spin, like so. Right, let's bring all values back. The glue node here is can be used for different purposes, but can be used for different purposes. But now let's leave it. Collision. Here you can see the collision geometry and define the resolution of it. So let's come closer, and to see the actual collision geometry, we need to turn off the actual geometry like this and show guide geometry. So alright, this blue one tells us the actual geometry, but you can see that resolution of the pieces is really different. So I'm missing the small one here, and for example, this one, it has okay, this one it has really high resolution comparing to this one. This is not nice way to work, because some small pieces will be really heavy for calculation and not accurate, and the big one will be fast but inaccurate. To solve this problem, there is a division method list, and from max axis you need to switch by size. In that case, all the pieces will be the same in resolution. So now I'm missing the small one, and to get them back I need to decrease division size. So default one is 0.1. I will set 0.05, and here we are. I got a small one. If I set it even smaller, I get more. But you should be careful, because this function takes a lot of memory, and you can basically run out of memory. And now you can see that my viewport is not reacting because I set really low division size, and it will take some time to calculate it. So let's wait a bit. Maybe it will take not so long. Well, yeah, okay. Now I have really nice geometry. You see, all the details are defined, and this is really high res, pretty high res. I don't need this now, so I will put it back 0.5. So probably the small pieces will fall down through the ground or collide, not precisely, but for demonstration purposes, this is fine. Okay, so let's turn off collision geometry and turn on the real one. Next tab is physical, and here you see compute center of mass. So Houdini is clever enough to compute center of mass. It calculates it for each piece, and it gives a really high quality result in the end, but takes time to compute. But you by default you shouldn't turn this off because the simulation will be just not unnatural. Okay, compute mass. There is two ways to compute mass of object for in Houdini. The first one is density. So basically, we know the density of material, and Houdini will calculate mass of each piece according to its density, to its material density. Um, because basically, this little piece can weigh few hundred kilos or less than 1 gram if I set it to compute mass. But if I set if I turn off compute mass and set it by manually, but if I have compute mass activated, then all the pieces will have a proper weight, which is essential for simulation. Okay, so density now is 1000. Let's leave it for a moment. Rotational stiffness. It's physical. Well, there is a lot of physical parameters, so you need to play with them to see how it works. And sometimes you need to crank up numbers really high. So let's don't touch this. Bounce. Well, this parameter is obvious, and it basically tells how bouncy the object is. If I set it to 2 and turn off initial velocity, okay, bounce is 2. You see it's just exploding. After a few jumps, it's explode. The reason is that bounce, I'm not sure, but it looks like it works in percents. So basically 2 is 200%. If I set it to 1, it should okay, it start to do little movement here. But if I set it to, for example, 1.2, okay, nothing happens. Yeah, probably because the value is not so critical, but if I give a little velocity, so I will have some movement on scene, in scene. Yeah. Okay, it attenuates. What if I set 1.5? So now you see the simulation become unstable, and columns start jumping on place. So you basically need to play with these parameters to find the correct one. I will leave it on default. Friction is friction. It's a useful thing, for example, if you want to simulate the asphalt or ice, you really want to change this parameter. The friction here is static. It works when the object is not moving, but here is also dynamic friction, which works when the object has any the force, so it moves. Okay. If I set it to 0, it's sliding. It's really sliding a bit. Okay, let's move back to 1. Temperature, it's useful for gas and water simulation. Yeah, used in gas simulations for ignition, Okay, and buoyancy. Buoyancy is used not only for gas but also for water. All right, let's leave it. And uh, velocity is 0, and nothing happens in the scene. My geometry actually is sliding a bit. Um, Probably because it's perfectly flat, so glue doesn't work. Well, okay, glue works in this part, but not here. Um, I think if I wouldn't have this, it'll be fine. Um, but this is not nice. I need to think how to solve it. Yeah, I'll talk about it a bit later, maybe. All right. Uh, so um, column. All right, glue constraint. Now it's time to talk about glue. If you select glue constraint, you can see that there is a strength, which is 10,000 for now, and half-life. The half-life is telling how much time should the number of seconds um, for the glue impulse to decay by 1/2. Okay, I'm reading it, but just it's right. Let's say strength to 100, and you can see that the columns start falling apart by itself, even if there is no impulse. If I set it to 0, it will start falling apart even earlier. Okay, and let's say if I set it to 1000, it's holding, but slowly, okay, it's moving, so now it will start falling apart. Yeah, you can see it. And glue force is becoming weaker and weaker. What if I set to 0.01? Oh. No, okay, well, probably it will work on different situation. Okay, the glue strength is 1000 and the object is standing still. Well, relatively. Let's give it 5000. Okay, it's not falling apart here. Now we can create impact object, which is, for example, sphere. So I'm going back to geometry level and create sphere. Move it aside. Okay, like this. And I need to make it dynamic object. In rigid body tab, there is a RBD object, the first icon. So I select my sphere, I click on RBD, and it turns my sphere into RBD object. And in Autodesk Network, you can see that I have my sphere. It also has all the parameters, initial state, and collision, and okay, let's see how. Well, it's pretty dense geometry, so I will decrease it just to make calculation faster. Too much. Okay, that's fine. This is fine. All right, and now if I play the animation, my sphere just falling down. Well, it happens because there is no initial force, and let's say initial velocity minus 10. So the sphere is coming forward, hitting the column, and nothing happens because there is not enough force to break the glue. I can increase velocity, for example, minus 30. The sphere coming forward faster, it's crashing, looks really nice. That's frame by frame. Yeah. Okay, it hits really nice, but there is a few options you can work with. Let's say I want to have very small sphere. I can create the warp object like this, hide it, and do simulation, or if I don't want to, I can make this sphere smaller, for example, like this. And let's play animation. And now you see that there is not enough force, but I just changed the size of the sphere. The reason is that in physical tab, it calculates mass according to density. So it takes density calculated over size of the volume of the sphere and the mass becoming really small. If I want to make this sphere really, really heavy, I can turn off compute mass. So now this has 1 kilo, it weighs 1 kilo, and it's not even hit the column, which is logical because column is pretty heavy. If I increase the mass, let's say this is 100 kilo, and it hits the column, now there is impact force, which is enough for destruction. Okay. Okay. Let's try to simulate the real world thing, and I'm not sure which material the column is made for, so I took the common how it's called, wait a second, I'll take granite, and Wikipedia says that it weighs not weights, the um, density is 2600. Okay, and the cannonball is made from iron, which is 7,600 if I remember it right. Well, yeah, Wikipedia says so, something like this, or maybe even like this. All right, so let's try to play. Okay, the cannonball will easily break the column, and initial velocity, I guess it's in meters per second. So to make the physical calculation, I can, for example, create a grid like this, and let's say size 100 meters by 100 meters. So one square is a square meter, right? Here is my sphere. Let's hide the ground. Okay, so roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 meters, and something goes wrong. Why? Oh, sure, I forgot to type a velocity. And I guess it's in meters per second, so minus, which is direction, 30 meters per second. So in 24 frames, it should go through 30 square meters. Well, yeah, it's in meters per second. Okay, so here we have a cannonball with not real speed, but something, which is hitting the column and it's crashing. It's crashing